Hello students. So, in my last sessions I have we have started something on group 17 elements, which is halogens. So, in that I have generally covered in that first session we have seen general properties like physical properties, chemical properties, general for all those halogens. And in the next session I have dealt with the anomalous properties of fluorine, and then we went to chlorine, preparation and properties of chlorine. So, today I shall take upon the next important compound which come in the group 17 element, which is nothing but hydrogen chloride. Or it is simply called as HCl. See, actually it was generally prepared by Glauber by treating manganese dioxide with the concentrated sulfuric acid, and once again in 1810 Davy said that this hydrogen chloride contains hydrogen and chlorine. Now, we shall move on to the method of preparation. So, in this method of preparation you have been given with only one method of preparation, which is nothing but heating sodium chloride, which is nothing but NaCl, with concentrated sulfuric acid. If you heat sodium chloride with concentrated sulfuric acid, we end up with HCl. If I write the equation, I have NaCl plus H2SO4 will give you NaHSO4 plus HCl. If you see students, the equation is balanced over here, so there is no much problem in this case, and the reaction will proceed. Whatever the NaHSO4 I have got over here, that will react with another molecule of NaCl, and finally we end up with Na2SO4 and HCl. So, we have to write some temperatures there. So, here as I have said, it is heating. In the first case it is 420 Kelvin temperature. So, at that temperature if you heat sodium chloride with sulfuric acid, we end up with sodium hydrogen sulfate along with HCl. And next whatever the byproduct which is obtained there will react with another molecule of NaCl at a slight higher temperature of around 823 Kelvin, and we end up with this one. Suppose if you add on the equations, students, now what generally happens? So, NaCl and NaCl, I have 2 NaCl will react with H2SO4, and finally we end up with Na2SO4 and 2 HCl. This also you can remember as such. The thing over here, that is NaHSO4 on both sides, that is bisulfides of sodium, this gets cancelled, and hence I have the overall reaction. Only one method of preparation, that is treating sodium chloride with concentrated sulfuric acid. Okay. Next we shall move on to properties. Properties of HCl. Now, properties given over here are 1. So, this is a pungent smelling gas. Okay. So, this ಒಂದು ಘಾಟು ವಾಸನೆ ಇರ್ತದೆ ಅದಕ್ಕೆ, and this is usually colorless. We have seen for chlorine, chlorine was a greenish yellow gas, isn't it? So, this is colorless and it is readily soluble in water. HCl gas, when passed to water, we end up with hydrochloric acid. Okay. Hydrogen chloride, highly soluble in water. When dissolved in water, we end up with hydrochloric acid. If I write the equation for this here, I have HCl plus H2O will end up with H3O plus Cl minus. Now if you write the Ka value, that is dissociation constant, that accounts to be 10 to the power 7. So the value is high, indicating that this hydrochloric acid, that is the solution of hydrochloric acid in water, behaves as a strong acid. So you know that hydrochloric acid, concentrated hydrochloric acid, which you use for flame test and all, isn't it? So fumes, you will end up with fumes and all. So this is a strong acid because of its higher value of Ka, that is dissociation constant. This is regarding some of the properties, and melting points and boiling points have been given to you over there. It can be easily liquefied to a colorless liquid which will boil at around 189 Kelvin temperature, and it will also crystallize to a white solid with the melting point of 159, that is freezing point of 159 Kelvin. Okay? So that I am not going to write here. So these are the two important points. Now if you go for the reactions or reactivity, so three reactions have been given to you here. We shall see one by one. Reactions. So first one with ammonia. So this generally will end up with dense white fumes of NH4Cl. If I write the equation, I have NH3, HCl will react with that NH3 and will end up with NH4Cl. See students, this you have done in your practicals. ಹೌದಿಲ್ಲ, ಫಸ್ಟ್ ಇಯರ್ ಪ್ರಾಕ್ಟಿಕಲ್ಸ್ನಲ್ಲಿ ನಾವು ಎರಡು ಇದರಲ್ಲಿ ಮಾಡಿದ್ವಿ. ಒಂದು ಗ್ರೂಪ್ 2 ಕ್ಲೋರೈಡ್ ಅಯಾನ್ ಡಿಟೆಕ್ಷನಲ್ಲಿ ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ ಸಲ್ಫ್ಯೂರಿಕ್ ಆ್ಯಸಿಡನ್ನು ಹಾಕಿದಾಗ ಕಲರ್ಲೆಸ್ ಗ್ಯಾಸ್ ಇಸ್ ಇವಾಲ್ಡ್ ವಿಚ್ ಗಿವ್ಸ್ ಡೆನ್ಸ್ ವೈಟ್ ಫ್ಯೂಮ್ಸ್ ವಿತ್ ಎ ಗ್ಲಾಸ್ ರಾಡ್ ಡಿಪ್ಡ್ ಇನ್ ಅಮೋನಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಅಂತೀವಿ. ಸೊ ದ ಸೇಮ್ ಒನ್ ಹಿಯರ್. ಅಥವಾ ಡಿಟೆಕ್ಷನ್ ಆಫ್ ಅಮೋನಿಯಂ ಅಯಾನ್ನಲ್ಲಿ ಡಿಟೆಕ್ಷನ್ ಇದ್ದಾಗ 0 ಗ್ರೂಪ್, ಅಲ್ಲಿ ಕೂಡ ಹಾಗೆ ಆನ್ ಆ್ಯಡಿಂಗ್ ಸೋಡಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಆ್ಯಂಡ್ ಬಾಯ್ಲಿಂಗ್ ಇಟ್. ಸೊ ಏನು ಮಾಡ್ತೀವಿ, ಪಂಜೆಂಟ್ ಸ್ಮೆಲ್ಲಿಂಗ್ ಅಮೋನಿಯಾ ಗ್ಯಾಸ್ ಇವಾಲ್ವ್ ಆಗುತ್ತೆ. ಸೊ ಅದಕ್ಕೆ ನಾವು ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ HCl ನಲ್ಲಿ ಅದ್ದಿದ ರಾಡನ್ನು ಇಟ್ಟಾಗ ವಿಲ್ ಎಂಡ್ ಅಪ್ ವಿತ್ ಡೆನ್ಸ್ ವೈಟ್ ಫ್ಯೂಮ್ಸ್ ವಿಚ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಅಮೋನಿಯಂ ಕ್ಲೋರೈಡ್. ಸೊ ಜನರಲಿ ಒನ್ ರಿಯಾಕ್ಷನ್ ರಿಯಾಕ್ಟ್ಸ್ ವಿತ್ ಅಮೋನಿಯಾ ಟು ಎಂಡ್ ಅಪ್ ವಿತ್ ದ ಡೆನ್ಸ್ ವೈಟ್ ಫ್ಯೂಮ್ಸ್ ಆಫ್ ಅಮೋನಿಯಂ ಕ್ಲೋರೈಡ್. ನೆಕ್ಸ್ಟ್ aqua regia. So aqua regia preparation, we make use of HCl. Aqua regia is nothing but a mixture of 3 parts of concentrated HCl and 1 part of concentrated nitric acid, HNO3. So this mixture is called as aqua regia. Now what is the use of this aqua regia? So this is useful to dissolve noble metals like gold, platinum, silver, etc. Okay. Aqua regia, it is a mixture of 3 parts of HCl and 1 part of concentrated nitric acid. ಇವೆರಡನ್ನ ಮಿಕ್ಸ್ ಮಾಡಿದಾಗ ಬರುವಂಥ ಸೊಲ್ಯೂಷನ್ aqua regia. This aqua regia is useful to dissolve noble metals like gold and platinum. We shall see the equations now. If I take gold, Au, ionic equations have been given to you students, so I will write the ionic equations only. I have H plus it is present in both HCl as well as HNO3, and NO3 minus which is in the nitric acid, and I have Cl minus. Now this I will end up with the complex of gold. So I have Au Cl4 minus, and this NO3 gets converted to NO, and this H and O will react to give H2O. So, ಈಗಾಗಲೇ ಹೇಳಿರೋ ಹಾಗೆ unbalanced equation ಗೆ marks ಇಲ್ಲ. Now, you have to balance this. How will you balance? So, in order to balance this equation, we will apply the concept of oxidation number. Now, if you just see here students, gold with the oxidation number 0, it is becoming plus 3. I hope you can calculate here, because for chlorine it is minus 1, 4 such are there. So, x minus 4, this is equal to minus 1. If you calculate the value of x, that accounts to be plus 3. Okay. Now, one more changing is this one. In the case of NO3 minus nitrogen, this is also having plus 3. See here, oxygen always minus 2. So, 2 into minus 2 into 3 is 6. So, I have x minus 6 is equal to minus 1, and hence the oxidation number will be plus 5. Sorry, I said it as 3, sorry, plus 5. Now, in this case, if NO, oxygen is minus 2, and hence nitrogen is plus 2. Now, if you just check students, from 0 to plus 3, there is an increase in the oxidation number of 3 units, and from plus 5 to plus 2, there is a decrease in the oxidation number by 3 units. So, all these will be multiplied by 1 only. Now, balancing ಮಾಡಲಿಕ್ಕೆ ಇದು ಮಾಡೋ extent of oxidation ಮತ್ತು extent of reduction ಏನಿರುತ್ತಲ್ಲ ಅದರಿಂದ multiply ಮಾಡಿದರೆ, so here it is all 1 only. So, we do not have to multiply the things. Now, let us generally try to balance the things here. Simple. So, I have 4 chlorine, so I will make it as 4 Cl minus, and then I have there how many H2O it is there. So, in that case, so here I have 3, I have 1 and only 1, so I have to make it 3. So, I will multiply this by 2 H2O, ಅಲ್ಲಿಗೆ 3 oxygen ಆಯಿತು, ಇಲ್ಲಿ 3 oxygen ಆಯಿತು, then last I am left out with hydrogen, 2 into 2, 4 hydrogen, I have 4 H plus. Simple one. Next, if one more given to you is for platinum. Platinum will react with the same salt, H plus, NO3 minus, Cl minus. So, platinum is PtCl6 minus. Illi 4, illi 6, only that is the difference. Same NO, H2O. Now, if you balance in the same scenario, what I have told, Pt is 0. Now, illi calculate madidre, this accounts to be plus 4. So, here I have 6 minus 6, akade hodre plus 6 minus 1. So, I have plus 4, and in this case also here I have plus 5, and this is plus 2. Now, if you just check out the change in units here, for platinum it goes from 0 to plus 4. So, I have to multiply this by 4 here, and here also it should be multiplied by 4. On the other hand, nitrogen from plus 5 to plus 2, change in units is 3. So, this Pt will be multiplied by 3. I hope you are clear. So, idella concept galu nimage first year oxidation number balancing nalli ide. So, I hope you can recall with those things. Now, you can balance the rest ones. Now, in this case I have 3 into 6, it is 18 Cl. So, I should have 18 Cl minus, and then I have here what else left students. Now, if you just see oxygen, 4 3s are 12 oxygen, and I have only those things here. Here I have 12O, here I have 4, and remaining is 12, in the sense I have to multiply it by how much, 4 3s are 12. So, in this case it should be 8 H2O, 8 plus 4 12, it is clear. And lastly, I have to balance that hydrogen, only here I have hydrogen, 8 2s are 16, I have 16 H plus. So, this is how you balance the given equation. That is Aquaria preparation, uses and equation. So, in this preparation hydrogen chloride is made use of. Okay. Then last one reaction given to you is reaction with the salts of dilute acids have been given to you. We shall write that also now. Third set of reaction, salts of dilute acids. So, like carbonates, sulfites, bisulfite, etc. So, in this if you just check carbonates, I have simple sodium carbonate is given to you. This on treatment with HCl. See, carbonic acid H2CO3 adondu weak acid, weak acid in a salt, sodium salt tagondidane. Now if you treat it with this simple reaction, I will end up with NaCl, carbon dioxide will be evolved with water. Now you might have done salt plus dilute H2SO4 in your practicals. Any acid ನೀವು ತಗೊಳ್ಬೋದು, ಕಾರ್ಬೋನೇಟ್ ಸಾಲ್ಟ್ ಇದ್ರೆ ಏನಾಗುತ್ತೆ ನಮಗೆ ಬ್ರಿಸ್ಕ್ ಎಫರೆಸೆನ್ಸ್ ಬರುತ್ತೆ ಹೌದಿಲ್ಲ, ಏನಕ್ಕದು ಡ್ಯೂ ಟು ದ ಇವಲ್ಯೂಷನ್ ಆಫ್ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಗ್ಯಾಸ್. ಸೊ ಹಿಯರ್ ಆಲ್ಸೋ ಇಟ್ ಈಸ್ ಸೀನ್. ನೌ ಯು ಹ್ಯಾವ್ ಟು ಬ್ಯಾಲೆನ್ಸ್ ದಿಸ್. ಐ ಹ್ಯಾವ್ 2 Na over here, so we should make it as 2 NaCl and this becomes 2Cl. I have 2 HCl and rest the things are balanced. Next if I take a sulfite Na2SO3, so this is made up of sulfurous acid, a weak acid. If you treat it with this HCl, I will end up with same NaCl. Instead of carbon dioxide, I have sulfur dioxide being liberated in this case along with water. So balancing is in the same type, 2 HCl, 2 NaCl. If you take bisulfite, which is nothing but NaHSO3, in this case also it reacts with HCl, same products, NaCl, sulfur dioxide which is SO2 and H2O. In this case I have only one Na and hence the equation is self balanced. One H is here and one H here, total 2H. So this is regarding reactions of hydrogen chloride. Now we have seen the preparation and also we have seen the reaction. Now what is the use? The last set, uses. So uses of HCl, so one majorly used as a lab reagent. We usually make use of this as dilute acid or concentrated acids. Generally it is used in lab. Sometimes it is also used for medicinal purposes also it is used, and generally in the preparation of ammonium chloride, which is nothing but NH4Cl. We have seen treatment of ammonia ends with ammonium chloride, and it can also be used in the preparation of chlorine. In my last class I have told action of MnO2 with HCl or KMnO4 with HCl, it is used, and also in the preparation of glucose. We need an acid medium which you will study in the chapter on biomolecules there, students. So in this case preparation of glucose usually from corn starch makes use of this HCl. So this is regarding uses of HCl. So next we shall move on to the next compounds of halogens, which are nothing but oxo acids. In that oxo acids you have been given with only for the oxo acids of chlorine. So next we shall take upon this oxo acids. See, oxo acids generally fluorine will form only one oxo acid. So fluorine only one oxo acid, so which is usually HOF. Hypochlorous acid anta karitare adana, only one. Yake? Because of its more electronegativity and it is a small size and others. So, it is not able to form many oxo acids, while others they form many oxo acids. So, we shall see those one by one. I shall write a table now, we will analyze those things. Okay. Okay students, I have the table of oxo acids for you here. Now, here I have these all as halic acids. In that case, I have HOF, HOCl, HOClO, HOClO2, HOClO3 and this many. Among this, you have only the oxo acids of chlorine. Only this oxo acids are there for you and rest are not there, and you will be asked to write the structures of these oxo acids. Now, if you just go through these oxo acids, students, it is clearly seen that in these cases all those halogen exhibit variable oxidation states. It may be of +1, +3, +5 or +7. We shall look into the structures of these 4 now. Okay students, so I have the equations for you here, equations in the sense, sorry, structures. Now, we shall see these things one by one. I have already drawn this for you over here. See, first one, hypochlorous acid, HOCl. So, in this case of hypochlorous acid, the structure is here, oxygen valency 2. So, one satisfied by hydrogen and other satisfied by chlorine. Next, I have chlorous acid. See, students, if you compare the two, ಏನು difference ಇದೆ ಅದೆರಡಕ್ಕೂ? ತುಂಬ ಏನು difference ಇಲ್ಲ ನೋಡಿ, ಇದು HOCl. This contains one more oxygen and hence it is chlorous. Naming it is named as chlorous acid. ನೀವು ಇಲ್ಲಿ chlorine oxidation number calculate ಮಾಡಿದ್ರೆ, so in this case here it is -1, in this okay, this is -2, hydrogen is +1 and hence chlorine will have a +1 oxidation state here. ಇಲ್ಲಿ ಇದು +1 ನಲ್ಲಿದೆ. Now, here if you take oxygen -2, -2, -2, -4, +1. So, chlorine will have an oxidation state of +3 in this case. So, here in the first case it is +1. So, even ನಿಮಗೆ ಫಾರ್ಮುಲಾ ಹೀಗೆ ಕಷ್ಟ ಆಗುತ್ತದೆ ಅಂತಂದರೆ you can remember it as HClO2 ಹೀಗೆ ಸಹ ಬರೀಬೋದು, both are one and the same. So, here it is separately taken. Now, in this case same structure ಇರುತ್ತೆ, ಬಟ್ ಒಂದು O ಜಾಸ್ತಿ, it is indicated by a double bond O. ಸಿಂಪಲ್ ಇಲ್ಲೇ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೋದು ನೋಡಿ, 1 ಬಾಂಡ್, ಹಾಗಾಗಿ ಇದು +1, ಇಲ್ಲಿ 1, 2, 3 ಬಾಂಡ್ಸ್, ಸೊ +3 ಈಕ್ವಲ್ ಶೇರಿಂಗ್ ಆಗುತ್ತಲ್ಲ ಹಾಗೆ. ನೆಕ್ಸ್ಟ್ ಇಫ್ ಐ ಆ್ಯಡ್ ಸ್ಟಿಲ್ one more O is added over here, I'll end up with HClO3. So, this is called as chloric acid. You know, right, sulfurous acid, sulfuric acid, in difference, just the oxidation number of sulfur is changing. In the same way, here also the oxidation number of chlorine is changing. In this case, oxidation number will be +5. So, the structure illide, idikke innu ಒಂದು O ಸೇರಿಸ್ಕೋಬೇಕು. So, one more double bond O is increasing. So, I have 2 double bonds O followed by 1 single bond OH, indicating the oxidation number of chlorine to be +5 in chloric acid. Next, last one, perchloric acid, HOClO3, or you can write it as HClO4. So, this is known to be the strongest acid, perchloric acid. In this case, the oxidation number of chlorine will be +7. So, see, similar to this, but I have a 3 oxygen linked by means of double bonds to chlorine, 2, 4, 6 and 1, 7. So, oxidation number will be +7. So, students, just to focus on these oxo acids, especially structures of oxo acids of chlorine. Formula, hypochlorous acid is HOCl, chlorous acid you increase 1 O, which is nothing but HOClO or HClO2. Chloric acid increase 1 more O, HOClO2 or HClO3. Lastly, perchloric acid, HClO4 or HOClO3. So, in these oxo acids, as we have said, they exhibit variable oxidation states that can be clearly seen here from +1, +3, +5 to +7. So, this is something regarding oxo acids of halogens. Fluorine will form only one, while others will form many oxo acids. among which the structures of oxoacids of chlorine have been told to you. Next we shall move on to the last concept on interhalogen compounds. Last set of compounds of halogen is interhalogen compounds. Now students, in my previous session I have said that the halogens react with one another. One halogen will combine with another halogen, and in that case we end up with this interhalogen compounds, a binary compound of halogen with another halogen. So this results in the formation of interhalogen compounds. They can be of the type X, X dash, X, X dash 3, X, X dash 5 and X, X dash 7. I have already said in this case X stands for a large size halogen atom and X dash stands for small size halogen atom. And these numbers illenu barililla andre it indicates as 1. Okay. So illi this 1, 3, 5 and 7. So this generally depends on the difference in the ratio of radii of these halogens. Iga for example X, X dash 7 alli IF7 matra irodu. Because iodine ellide last allide, fluorine ellirodu first irodu, and fluorine has got the smallest size. That ratio enirte, a size in a ratio tumba doddirodrinda more number of fluorine atoms are required to form a compound like this. Okay, this is regarding those. So and one more thing, X is more electropositive than X dash. Idondu point nenapalli itkoli. We shall move on to the preparation now, or methods of preparation. So preparation is very easy, just direct a combination of those halogens. Nimage yava interhalogen compound beku, adralli yav halogen ide adannu togolli react ಮಾಡಿ. There is no conditions as such, but in certain cases some temperatures and pressures are needed, which we will see now. That's it. Okay. Or in some other conditions, smaller interhalogen compounds can also be treated with halogens to end up with other type of interhalogen compounds. But generally ನಿಮಗೆ ಕೊಟ್ಟಿರುವಂತದ್ದು ಎರಡು ಹ್ಯಾಲೋಜನ್ನಿನ reactions ಅಷ್ಟೇ ಕೊಟ್ಟಿದ್ದಾರೆ. We shall see one by one. Suppose if I take the first one, one more point here students, ಇಲ್ಲಿ example ಬರಿಬೇಕಾದ್ರೆ X can never be fluorine. ನೆನಪಿನಲ್ಲಿ ಇಟ್ಕೊಳ್ಳಿ, X fluorine ಆಗಲಿಕ್ಕೆ ಸಾಧ್ಯನೇ ಇಲ್ಲ, ಯಾಕಂದರೆ fluorine has got the smallest size. ಹಾಗಾಗಿ ಫಸ್ಟ್ ಈಗೆಲ್ಲಾದರೂ ಈಗ ನಾವು FCl ಅಂತೆಲ್ಲ ನೀವು ಬರೀಲಿಕ್ಕೆ ಬರೋದಿಲ್ಲ. This is not an interhalogen compound. Why? Because first comes X. ಈ X ಇನ size ಜಾಸ್ತಿ ಇರಬೇಕು. So F cannot come first. F ಏನೇ ಇದ್ರೂ ಸೆಕೆಂಡ್ಗೆ ಬರಬೇಕು ಹೊರತು ಫಸ್ಟ್. ಬಟ್ Cl ಬರ್ಬೋದು. Cl ಬಂದಾಗ ಅದ್ರ ಜೋಡಿ F ಇರ್ತದೆ. Okay. So this one point you just remember here students. Okay. Next we shall move on to the preparation. So few on the 4-5 preparation methods have been given to you, and I'll write that. So I have Cl2 reacting with F2 and I'll end up with 2ClF. These questions usually will be asked for complete the following type. So instance you can recall and write, I guess. So I have Cl2 reacting with F2 and I'll end up with the 2ClF. In this case the temperature used over is 437 Kelvin, and all these have been taken in equal volume. Now I may also take this Cl2 and make it to react with the 3 molecules of fluorine. In this case I have taken fluorine in excess. So I'll end up with, see here I have 3, so 2ClF3, this type, XX-3 type. So I'll end up with the 2ClF3. In this case the temperature is around 573 Kelvin. Next I can take I2 plus Cl2, I'll end up with ICl, 2 ICl, both in equimolar, same volume. If I take, I'll end up with this one, or if I take this in excess, I'll write here. So I have I2 plus 3 Cl2. In this case, I'll end up with, say, similar type, 3F2. So I have taken 3 Cl2 there. So I'll end up with 2 ICl3. Here I have taken chlorine in excess. Okay, one more we'll write for bromine also. If I take Br2 plus F2 diluted with water, so if we have been given with 3F2, in this case I will end up with the 2 BrF3, and last one example or preparation, 5F2, that is fluorine is taken in excess. In that case I will end up with 2 BrF5. IF7 matra irodu, so uldidella illi kottidare. So this is how we prepare these things. So depending on certain condition, direct combination of the different halogens will end in the formation of interhalogen compounds. So these are the things given to you in your textbook. Okay. Next we shall see some of the properties of these interhalogen compounds. Now if you go or compare the properties of these halogens, that is interhalogen compounds with halogen, we have certain points to say over here. In this case, all these molecules, they are covalent in nature, or they are covalent molecules and are diamagnetic substances, dia. The molecules are covalent, they are diamagnetic, that is they are not attracted by the magnet, you know those things. And next, almost all of them are generally solid or liquid, that is they exist either as solid or liquid except CLF. So this is a gas. CLF ಒಂದನ್ನು ಬಿಟ್ಟು ಮತ್ತೆ ಉಳಿದ ಎಲ್ಲ interhalogen compounds ಸಾಮಾನ್ಯವಾಗಿ they exist as solids or liquids which are generally they are volatile in nature. Okay. And individual halogens ಗೆ ಹೋಲಿಸಿಕೊಂಡ್ರೆ in comparison with the individual halogens, all those the properties are comparable to those, that is properties of interhalogen compound. I write it as a HC. It is comparable to halogens. So except their boiling points and melting points. Boiling point, melting point bitre. This is usually boiling points and melting points are low. Now general idralli low alla, high, sorry. Andre halogens low irtade, so these are usually high. So slight higher irtade, and rest all properties are of comparable to those of halogens except the boiling point and melting point. Now whenever you come to the chemical properties or reactivity, you can say that interhalogen compounds are more reactive than halogens except fluorine. See, this point is important, students, over here. Now see, interhalogen compounds, they are more reactive than halogens except fluorine. Fluorine ಗೆ ಹೋಲಿಸಿಕೊಂಡ್ರೆ interhalogen compounds ಅಷ್ಟು reactive ಅಲ್ಲ. ಬೇರೆ halogens ಗೆ ನಾವು ತಗೊಂಡ್ರೆ ಅಂದರೆ chlorine, bromine, iodine ಅದಕ್ಕೆ ಹೋಲಿಸಿಕೊಂಡ್ರೆ these interhalogen compounds are more reactive. Now why? Why are they more reactive? You may have a question, why? See, the reason for that is, now the comparison is X and X and X and X dash. So this is your simple halogen, and here this is the interhalogen compound. Now reactivity ಅನ್ನು ಹೇಳಬೇಕಾದ್ರೆ ಎಷ್ಟು ಸುಲಭದಲ್ಲಿ ಈ ಬಾಂಡ್ ಬ್ರೇಕ್ ಮಾಡ್ಬೋದು ಅನ್ನೋದ್ರ ಮೇಲೆ ರಿಯಾಕ್ಟಿವಿಟಿಯನ್ನು ಹೇಳ್ತೇವೆ, ಕರೆಕ್ಟ್. Now here also that comes into a picture. In the case of halogen, this XX bond enthalpy or bond dissociation energy, whatever we say, that is usually bit high, and hence it is bit difficult to break the bond between two halogen atoms. You can break but requires slight higher energy. On the other hand, in the case of interhalogen compounds, this XX dash bond enthalpy or bond dissociation enthalpy, this is quite low, and hence we can easily break the bond. Once you can easily break the bond, you can make it react with any other compound forming a new bond. In that case, these interhalogen compounds are more reactive than halogens. Now if you take fluorine, this I have already told in the anomalous property of fluorine. Bond enthalpy of fluorine is very, very less in comparison with other halogens. So yake, that also I have told, that is mainly due to the electronic repulsion of the lone pair of electrons, and hence this in comparison with the bond dissociation enthalpy of fluorine, fluorine has got the least one, and hence this fluorine is more reactive. And next comes interhalogen compounds with a slight higher bond dissociation enthalpy in comparison with halogen, and hence interhalogen compounds are more reactive than halogens except fluorine. So fluorine is most reactive, next interhalogen compounds, and next comes halogens. Then one more reaction given to you is a reaction with the water, that I will tell you now. Okay, last set of reactions is given with water, that is they all undergo hydrolysis with the water ending with the different products. If I just take a simple one, if I have X dash and treating with H2O, I will end up with HX dash and HOX. So this is generally we end up with the halide of small size halogen in generally HX dash, and this HOX, which we already know, this is nothing but hypohalite. Okay. Now if I take X dash 3, so I will end up with the same HX dash, I will end up with this one, and along with that I usually end up with halite, hypohalite. Next comes halite. If I just I can write the reactions for you also. X dash 3 plus H2O will end up with HX dash plus HOX 3. So this is halite. Next, if I increase the number XX dash 5 plus H2O, I will end up with HX dash plus HOX 5. This is halate ions, those, and lastly X dash 7 plus H2O will end up with HX dash 7 plus HOX 7. So this is perhalate. See, these equations are not given to you over there, students, just ನಾನು ಸುಮ್ಮನೆ ಹೀಗೆ ಬರೆದಿರುವಂಥದ್ದು ಅಷ್ಟೇ. So just one point ನೆನಪಲ್ಲಿ ಇಟ್ಕೊಳ್ಳಿ, ಇಲ್ಲಿ it was simple, I had X and X dash. In this case we may end up with the differences also, but just one ನೆನಪಿನಲ್ಲಿ ಇಟ್ಕೊಳ್ಳಿ, HX ಅಂತ ಏನು ಇಲ್ಲಿ ಬರ್ತದಲ್ಲ, HX dash, or I can just take over here, this is usually of small size halogen atom only. ಅಂದರೆ ಈಗ ನಾನು ICl ಅಂತೆಲ್ಲ ತಗೊಂಡ್ರೆ ಇಲ್ಲಿ CL ಇಲ್ಲಿಗೆ ಬರುವಂಥದ್ದು ಪ್ರತಿಯೊಂದರಲ್ಲಿ, ಇಲ್ಲಿ CL ಬರುವುದಿಲ್ಲ. So I will not end up with this. You just remember these names, it is sufficient. Okay, these equations are not that needed because I have X dash over here, so no need of these. In the case of XX dash, I will end up with one halide of small size halogen and one hypohalite. In the case of XX dash 3, same HX along with that halide. next I end up with halide, and lastly perhalate. So last bit left in this case is structures of these. So I shall write here, the structure of these can be analyzed by VSEPR theory. In that case, simple ones have been given to you. If it is of the type XX-3, this is a bent T-shape molecule. If it is XX-5, this will be square pyramidal. And lastly, if you say for IF7, only I do not have any other, only one, that is IF7, this is pentagonal bipyramidal. So all these shapes can be studied with the help of VSEPR theory. If it is of XX-3, the shape will be a bent T-shaped molecule. If it is XX-5, then it is square pyramidal, and lastly if it is IF7, it is pentagonal bipyramidal. So these are certain compounds, that is in general interhalogen compounds. So with these things, students, I shall wind up with the group 17 elements. So ಈ group 17 elements ನಲ್ಲಿ ಈಗ ಕಳೆದ 3 sessions ನಲ್ಲಿ just brush up ಮಾಡಿಕೊಂಡು ಹೇಳುವುದಾದರೆ, we have seen firstly the periodic properties, atomic size, ionization energy, electron gain enthalpy and electronegativity. We have seen some physical properties also like melting point, solubility and others. We went to chemical properties. In that we said something on oxidation states, and then we said something on the oxidizing properties and others, reactivity towards hydrogen, oxygen, and one more towards halogen, and metals and non-metals were discussed. In my next session I have taken something on anomalous properties of fluorine. We have said the reasons as well as properties. Next we went to the important compounds which come 17 elements. So first was chlorine. We have studied something more on the preparation and properties of chlorine. In today's session I have started with the hydrogen chloride preparation, properties and uses, and we have seen some oxo acids of chlorine, and finally interhalogen compounds.